All right, today we're going to take our first look at statistics. We're going to start with some of our more basic stuff. It's called probability. We've probably heard this word and we're familiar with what we're going to do here. We're just going to talk about a few types of probability. We're going to first start off by taking a few notes that you might have that you might want to write down. This is also a Delta Math assignment. We're going to go through the notes before we actually look at the Delta Math assignment though. So if you would, get yourself ready for that. So the first thing we're going to do is get ourselves familiar with some of the verbiage we're going to see. We probably won't use this right now, but you're going to see it throughout, and you need to know what it means when it shows up. A sample space is the set of all possible outcomes of an experiment. Now, when we say experiment, that it's the word that we're going to use for the events that can happen. So the sample space on a dice is the numbers 1 through 6. If I've got a spinner that's got 5 colors, the sample space is the 5 colors. But that is just all the possible outcomes that can happen. An event is some set of the sample space. That's a tongue twister there. So the event is what actually happens. So when I flip the coin, that is the event that happens. The sample space is heads or tails, but the event is what we actually see happen. And the probability of an event is the likelihood, that's the key word, that the event will happen as a proportion out of 1. Or a percentage out of 100. So a proportion out of 1 or a percentage out of 100. Our first thing we're going to work on is actually converting percentages to decimals and back and forth. But on proportions, what you need to do is recognize this. Think of it like a number line, and the top of that number line, the very highest you can get is 1, and the very lowest you can get is 0. I know that seems like a very small number line, but that's what we have. There's actually an infinite number of numbers between the numbers 1 and 0. If we are at 0.5, this means that the outcomes are equally likely. These are equally likely events. If the event falls below, and some of this sounds like common sense, and kind of it is, if the event is below 50%, the 0.5, that would be, and I said 50%, let's go ahead and label that as well. This is 0% chance of happening. This is 50% chance of happening. And this is 100% chance of happening. And we'll talk about that percentage in just a minute. But if we have on our bar values below 0.5, then it is unlikely to happen. The further left we go, the closer we get to 0, the less likely it gets. So if I have a 0.25 on my number line, that is unlikely to happen. But if I have 0.15, that is even less likely to happen. The closer I get to 0, obviously, the less likely. And then as we move to the other side, we are more likely. It is more likely to happen if it's over 0.5. And then, of course, if it's 50-50, it's equally likely on both sides. Now, I want you to pay attention to these words. If we have a value of 0, it is an impossibility. That means it cannot happen. And if it's a 1, it is a certainty. It is going to happen. There is no other outcome that can happen. It is a 100% chance. So we're looking at that. Now in statistics, you guys that might have played sports or anything else, and somebody said give 110%, statistically there is no such thing when we're talking about probability. 100% is 100%. That's why we'll never deal with a number higher than 1 when we're talking about probability. All right, and then the last thing we're going to see here, the notation for sample space is just a capital S. And then any letter we use is the events. Now we can list words and use entire phrases as our events here. Remember the way we convert a percentage to a decimal is we just move that decimal place 2 places to the left. And here is the heart of all probability right here. Make sure you have this written down. what probability is, first of all, we use capital P. And then if I say A, what I'm saying is probability of the event A happening, whatever that may be. That could be tails. We could use the word tails. We could use the word heads. Whatever we expect or hope to happen. Now, listen to this phrase. It says number of favorable outcomes. This is not an emotion. Favorable outcomes means the outcomes in which we are trying to see. So if I were, for instance, if I were doing a cancer research, obviously cancer is not a favorable outcome, but is the outcome that I'm looking into seeing. So don't think of favorable as good or bad, think of favorable as what I'm looking for. And then the second part, the denominator, is the total number of possible outcomes. That is oftentimes known as the population. That is everything. That would be our sample space if we look back at it. I want you to notice how this is written. We have the capital P, which again, that stands for probability. And then we have B, we have a vertical line, and then we have A. The way this reads is the probability of B given that we are talking about A. So we can use entire words that on this. We could say the probability of, I don't know what, let's say somebody having brown hair, and then we use this line right here, given that they are male. So that's how we would write that probability. But that's how that reads. The probability of this event given that event. All right, we're going to go to the delta math here. So if you're looking at those, we'll start doing some of our conversion stuff. So as we look at this, what we see is we are converting 52.3% into both a fraction and a decimal. I'm actually going to put this into a decimal form first. Remember, anytime we're looking at a percentage, we need to move the decimal place over 2 places, and then we are in the numeric form. Remember, a percentage is not a number, it's a representation of the number. And it is a representation of the number 0.523. Now I want you to notice on delta math, it's got a neat little trick here, and we're actually going to use it. This little section here is if we have a repeated decimal, which we do not. So you're going to type all of your stuff in right there. So now we're going to write this in fraction form. Now we've talked about tens, hundreds, and thousands throughout our academic career here. So what we have is the thousands place. So what we have is 523 out of 1,000. Now remember, this number actually does not reduce, this fraction does not, but remember we can go math, and then under that it's going to say fraction, and then it's going to say the answer. But if you just hit math, enter, it's going to convert your fraction into a reduced version of that fraction. So we're going to go math, enter. Remember, as we do these, percentages are not real numbers, they're representations of real numbers. So there's no point so that you should be putting a percentage into a calculator. You need to convert it to its decimal form. This is also a likely event because we are at a decimal higher than 0.5, just barely. So it's just a little more than likely, slightly more than likely, however you want to phrase this. As promised, I told you I'd give you a repeating decimal here. I'm going to let my calculator do all this work for me. So what this is, remember, fractions are just division. So this is essentially 7 divided by 12. 7 divided by 12 gives me 0.58333 repeated. And remember what this is 0.583 with a line over it. Now, repeated decimals go for any series of terms. Let's just take a little side trail here. if it would have been a number that repeated like 1, 2, 3, 1, 2, 3, 1, 2, 3, that is a sequence of 3 numbers that repeats. So we would put a line over the 1, 2, 3. And that's just letting us know that sequence is repeating itself over and over again. Now for this one, it's just the 3 that's repeating, so it would be 0.58 with a line over it. And then the second part, we're supposed to change this into a percentage. So that involves taking this decimal place, moving it over 2 times. So we are talking about 58.3 repeated percent. So this is what our answer should look like. And you're just going to skip this space right here and put that in just like it reads. So let's take a look at some of the verbiage. And again, Delta Math may use different verbiage than we see in other things, but you can reason these together and try to determine what they're talking about. It says Jen is playing a board game. The probability that Jen will lose a turn on his next turn is 12%. Which word or phrase describes the probability that Jen will lose a turn? Well, 12% is very close to 0, and as a decimal, it's 0.12, so it is very unlikely that Jen will lose on his next turn. Now, let's look at the words. Impossible, just to cover their phrases. Impossible means 0%. It cannot happen. Likely just means it's more than 0.5, and then equally is a 50-50 chance. You don't even have to say 50-50, just an equal chance. All right. Statistics is as much of a reading skill as is a math in some points. It's important to understand what you're looking for, how we're going to read tables, and what the data is saying. So make sure you do read carefully. It says Caden records the grade level and instrument of everyone in middle school of Rock below. It says 7th grade students. We have guitars, 8, bass, 15. We won't go through all this data. We'll look at the data that matters to us, and we don't know what that is until we finish reading. So based on these results, express the probability that an 8th grader chosen at random will play the bass as a decimal to the nearest 100ths. Okay, first of all, read through something more than one time. Not going to read through one time and immediately know the answer on this, but what you want to do is identify the information that we want. Based on results, the probability of an 8th grader. Well, we don't even need the 7th graders. This information is not even here. It doesn't say out of the whole school. It just says express the probability that an 8th grader. So that would be our given that they are an 8th grader. So if we were doing our probability, it would be probability of a base given that they are in the 8th grade. That's how we would write that as a phrase. So let's just go ahead and take a look at this. Well, the first thing we need to do is identify our population. So our total outcomes. Well, our total outcomes are only the 8th graders, not the 7th graders. So our total outcome is going to be the sum of all of these terms. The 13 guitar players, 3 bass, 6 drums, and 9 keyboards. Well, when we add all of those up, we have a total of 31 8th graders in this 8th grade, in this band class. So that is our total outcomes. Now our favorable outcomes, again, this is not your favorite instrument. This is just the information we're interested in. We're interested in those 8th graders that play the bass. So the 8th graders that play the bass are only 3 of the 31. So we are very unlikely to choose the bass players as a random selection. So our probability ends up being approximately 0.10. It did ask me for the hundredths place. It did not round up. So this would be our answer for our probability. So we've got a big chart here. Do not be overwhelmed just by the big chart. First of all, recognize what they're asking. A lot of times we see data like this and we just panic immediately. Let's just recognize what we're looking at. So it says the following table represents the highest education attained for adults in a certain town. If a resident who was 30 to 39 years old is chosen at random, what is the probability that they have completed their bachelor's degree and no more? So first of all, we need to identify what we're talking about. We are not talking about the entire population. It says if a resident is 30 to 39, that would be this category right here, not the population. So we don't care about the 20 to 29-year-olds. And by the way, I would not mark out these tables like I'm doing. You may need the data later. So I do not need this information. All I need is the 30-year-olds. And it says probability chosen at random that they would have a bachelor's degree. Well, a bachelor's degree is this category here. So we're just going to see where the two columns meet one another. So the number of favorable outcomes is 1,340. And our total outcomes is not the big number here because we're not drawing from everybody. We're only drawing from the 30 to 39-year-olds. So that would be our number at the bottom, 2974. So that's our probability, but we've got to make sure we answer the questions being asked, and it asks us to round this to the nearest thousands. That would be a decimal place of 3. So this would be 0.451. Unlikely because it is below 0.5. And our last example, it says the following table represents highest education. I do want you to notice this data has changed. This is a fresh, new, must be a new town because it says the same thing, but the data is different. It says educational attained by all the adults in a certain town. So this is a different town. All right. It says if a resident who is 40 years or older is chosen at random. Well, this group right here is 40 years or older, but so is this one. So we will be drawing from two tables. There's nothing in statistics that say we have to stay in one table, for instance. We can cover whatever the case may be. You may jump back and forth. They may ask for the 20-year-olds and the 40-year-olds. I'm not sure. So again, just read your data. So we have this resident who is 40 years or older is chosen at random. What is the probability they have completed their bachelor's degree and nothing more? Well, here's your bachelor's degree. The number of people that have gotten their bachelor's degree would be these two numbers right here. So what we need now is our favorable outcome and our possible outcome. So the total number of 40 years or older is listed here at the bottom. So that would be 227.95 plus 55.28 for a total of 8,323. So that is our total number of outcomes right there. That's our denominator. So now we need our numerator, which is the sum of the two groups of bachelor's degrees. So, sorry about that. So we are going to add 793 to 2172. And that is a total of 2935. So our probability is approximately 0.356. Now, if I were to be asked what is the percentage, all I do is move the decimal place over twice. This is your answer, by the way. That's what Delta Math wants, so make sure you give it what it wants. But if we were asked to do a percentage, we would just move that decimal place over 2 times, and we're ready to go. All right, you guys have an assignment there. Trying it a little bit different. I tried cutting it a little lower, but the penalties for a wrong answer are a little higher. So make sure you take your time, check your answers. I'm going to up the attempts as well. Make sure that you round the way that you're supposed to round, answer the way you're supposed to answer. If it wants a percentage or a decimal, stay on top of that. Good luck.